Welcome to the Walton Pi. Today we're going to go through a practice problem that would probably show up fairly early on in a Calculus 1 course, maybe Test 1 or Test 2, depending on how your class is structured. So before we get started, if you're not subscribed, please consider doing so. It really helps me to stay motivated to keep making these types of videos. Okay, now with that out of the way, if we're given this sort of problem, how can we do this? So if we are told that f of x is the square root of x minus 3, how can we use the definition of the derivative to find f prime of 12? Now because this is the derivative at a point, there are two different definitions we could use. The first one is the limit as x approaches a of f of x minus f of a divided by x minus a. The other one is the limit as h goes to 0 of f of x plus h minus f of x divided by h, except that was the derivative function equation, so we are going to just change both of those to a's because I have the other one stuck in my head. There we go. So those are the two ways to find the derivative at a point. Let's go through both of these to see that they both actually will give us the same answer. So for this first one, we get the limit as x goes to 12 of f of x square root of x minus 3 minus f of 12. f of 12 square root of 12 minus 3 square root of 9, that's a 3, divided by x minus a divided by x minus 12. Okay, how can we solve this limit? Well, what we're going to be doing is, because we have this square root piece that's making everything 0, we're going to multiply the top and bottom by the conjugate. So that's just multiplying the top and bottom by the same thing, except we change that one sign. So instead of x square root of x minus 3 minus 3, it'll be the square root of x minus 3 plus 3. So we do that on the top and bottom. And then this limit is going to be limit as x goes to 12. I'm going to not distribute the bottom out. So x minus 12 times square root of x plus x minus 3 plus 3. And on the top, when we expand all of that out, we get an x minus 3 minus 3 times the square root of x minus 3 plus 3 times the square root of x minus 3 minus 9. So those two terms cancel each other out, and what we are left with is the limit as x goes to 12 of x minus 12 divided by x minus 12 times square root of x minus 3 plus 3. X minus 12s will cancel. We're left with a 1 on the top. We can now plug in 12, and we get a 1 over 6. So that is how we would find the derivative at 12 using the first definition. Now how about the second definition? How would we do that one? Well, here we have the limit as h goes to 0 of the square root of 12 plus h minus 3 minus 3 divided by h. So let's rewrite that a little bit. So that's the limit as h goes to 0 of the square root of 9 plus h minus 3 divided by h. We're going to do a very similar thing, and we're going to multiply the top and bottom by the conjugate. Square root of 9 plus h plus 3 divided by the square root of 9 plus h plus 3. And this will give us the limit as h goes to 0 of 9 plus h minus 9 divided by h times the square root of 9 plus h plus 3. Those 9s will cancel, then we're left with h over h. So then those will cancel, and we're left with a 1 on the top. And this will then give us, when we plug in h equals 0, 1 divided by 6 as well. So both of these are going to give us the same answer, and both of these are valid ways to find f prime at 12. Thanks so much for watching. If this was helpful, please consider subscribing, and if you really liked it, please like the video. If you have other videos you'd like me to go over, please leave those in the comment section down below, and I hope you all have a great rest of your day, and good luck with all of your math.